Hi students, next conversion, that is important conversion, that is from alkenes to alcohols and alkanes and alkyl halides. Second one is from alkenes to aldehydes and ketones, and alkenes to acids and acidic anhydrides, and from alkenes to esters and alkenes to amides and acid chloride. These are the important conversions. We will discuss one by one, student. First one, from alkenes to alcohols and alkenes to alcohols and alkanes. First one, student, that is sorry first one, that is, sorry for the disturbance, student. Alkenes to, first one, alkenes to alcohols. First conversion is from alkenes to alcohols. First one, now take the alkenes example, student, that is CH2 double bond CH2, CH2 double bond CH2, that is ethylene. When ethylene react with hydrochloric acid HCl in the presence of CCl4, we get, that is CH3 CH2 Cl. In this first step, electrophilic addition reaction is involved. In this, the conversion of, that is ethylene is converted into ethyl chloride, that is A compound. Ethylene converted into ethyl chloride, we get ethyl chloride, that is conversion A, that is that reaction belongs to electrophilic addition reaction. This is ethyl chloride. When ethyl chloride react with aqueous KOH, what happens, that is aqueous KOH, we get, that is ethyl alcohol will be formed, that is CH3 CH2 OH, that is ethyl alcohol will be formed. This is conversion from A to B, that is ethyl alcohol, ethyl chloride is converted into ethyl alcohol in the presence of aqueous KOH. This belongs to nucleophilic substitution reaction mechanism. This conversion, the conversion of from A to B, that is belongs to nucleophilic substitution reaction. This is the simple trick. First conversion is completed, from alkenes is converted into alcohols. That means first step is alkenes, example ethylene. When ethylene react with hydrochloric acid in the presence of non-polar solvent, that is CCl4, we get, that is ethyl chloride. In this step is electrophilic addition reaction. In this step is called electrophilic addition reaction. Then after that, ethyl chloride react with aqueous KOH, we get ethyl alcohol. This belongs to nucleophilic substitution reaction. Why? Because this bond, generally bond cleavage in between carbon and chlorine, so this carbon getting positive charge and this chlorine getting negative charge. Here in this step, student, Cl minus is replaced by OH minus, that is K plus plus and OH minus. This Cl minus is replaced by OH minus, we get, that is ethyl alcohol will be formed. So this is conversion of ethyl alcohol, student. And one more direct step also there, student. If in case, now take the, when ethylene react with water in the presence of acetic hydrogen, that is in the presence of acid catalyst. You remember, student, ethylene react with water in the presence of acid catalyst, we get, that is ethyl alcohol also formed, CH3 CH2OH. This is also correct direct method, student. The conversion of from ethylene to ethyl alcohol, this is direct method. When ethylene react with water in the presence of acetic hydrogen, we get, that is ethyl alcohol also. This is also one production, and this is a two steps reaction. So this is only one step reaction. The conversion of ethylene is converted to ethyl alcohol, that in the presence of, that is hydration. This step is called hydration. Hydration means what? Addition of water. Addition of water in the presence of acid catalyst, we get ethyl alcohol. This is the simple trick. So this conversion of alkanes to alcohols. And one more thing, student, this same thing, student, this conversion from ethylene is converted into, what I said, ethylene converted into alkenes is converted to alkanes. Alkenes is converted to alkanes. So what happens, student, that is in the presence of, here same thing, student, here also same thing. When ethylene react with hydrogen H2 by nickel, that is catalytic hydrogenation, we get, that is ethane will be formed, CH3 single bond CH3. This is also conversion of ethylene to ethane, from ethylene to ethyl chloride, from ethylene to ethyl alcohol. This is a simple trick, student. This from conversion of from ethylene to ethyl chloride, this means ethyl chloride, student, ethyl chloride, this is ethyl chloride. Conversion from ethylene to ethyl chloride, conversion from ethylene to ethyl alcohol, this is also one method student. Ethylene to ethyl alcohol also, this is also one method student. From ethylene to ethane, this is also important conversion student. This is the simple trick student. Now second method student, from next conversion student, that is alkenes is converted into aldehydes and ketones. Alkenes is converted into aldehydes and ketones. Alkenes is converted into aldehydes and ketones. Now next conversion, now first one, that is next conversion is for conversion of from alkenes to aldehydes. First one of alkenes example, take the example, that is ethylene CH2 double bond CH2 double bond CH2, react with water. In the presence of acidic hydrogen, we know when the H2O generally we get that H plus and OH minus. H2O contain H plus and one OH minus. So we get that is this H plus will attack one carbon, OH minus will attack another carbon. We get that is CH3 CH2 OH. Ethyl alcohol will be formed. Ethyl alcohol will be formed. This is ethyl alcohol. So this ethyl alcohol again react with copper at 300 degrees centigrade, or PCC or PDC, everything, or Jones reagent or Colen's reagent, Sarret reagents. These are the what is the role of these reagents? These role of the reagent oxidizer. These are the moderate oxidizer. So here what is the role of this oxidation? Removal of hydrogen, that means dehydrogenating agent. What is the role of copper and PCC and PDC and Jones reagent? This role of copper is dehydrogenating agent. Dehydrogenating means removal of hydrogen. We get that is removal of 2 hydrogen. We get that is CH3 CHO. Aldehyde will be formed. This is a simple trick. Conversion from alkenes to aldehyde. Alkenes means that is ethylene. When ethylene in this first step is hydration, addition of water, we get is ethyl alcohol. When ethyl alcohol react with copper at 300 degrees centigrade to give acetaldehyde will be formed. What is the role of copper? This role is the, what is the role of copper? Copper act as a dehydrogenating agent, means removal of hydrogen. This is a simple trick. And next conversion, this alkanes to aldehyde is completed. Now next conversion is from alkenes to ketones. Alkenes to aldehyde is completed. Next conversion is from alkenes to ketones. So what is the example? Now take the example, that is propene, that is 1 propene CH3 CH double bond CH2, 1 propene react with water water in the presence of acidic hydrogen. We get generally this bond shifting towards here, this carbon getting negative charge and this carbon getting positive charge, that is H plus. Generally water it can H plus and OH minus. This OH minus will attack this carbon, H plus will attack this carbon. We get that is product is CH3 CH OH, then CH3. Secondary alcohol will be formed, so that is 2-propanol will be formed, that is secondary alcohol. You remember simple trick, this bond shifting towards right side, we get this carbon getting negative charge and this carbon getting positive charge. We know generally this positive charge will attack always negative charge side, this negative charge will attack always positive charge side. We get that is 2-propanol will be formed. This is a compound, 2-propanol will be formed. This 2-propanol react with again copper at 300 degrees centigrade, or PCC or PDC, any we can take any reagent. What is the role of copper? This copper act as a dehydrogenating agent. Copper act as a dehydrogenating agent. So that's why we get what is the production? Removal of 2 hydrogen, means 1 hydrogen from here, 1 hydrogen from here. We get that is acetone will be formed, CH3 C double bond O CH3 plus hydrogen H2 is elimination. This is the simple trick. The conversion of from alkenes to aldehydes is completed. The conversion of from alkenes to ketones also completed. This is the simple trick. In this first step is hydration, that means addition of water. Then after that the dehydrogenation, that means this first step is hydration. In this first step is addition reaction student. In this first step is addition according to the Markovnikov rule, and second step is elimination steps, elimination reaction student, that is dehydrogenating. This copper act as a dehydrogenating, so that's why the 2 hydrogen elimination from this carbon, 1 hydrogen taking from oxygen, we get that is acetone will be formed. This is the simple trick for conversion of from alkenes to aldehydes and ketones. And next one student, this conversion of from alkenes to acid, third one student, this conversion of from alkenes to acids, conversion of from alkenes to acid. Next conversion, student, that is next conversion is, now take the same example, student, that is one CH2 double bond CH2 double bond CH2, when ethylene react with HCl in the presence of CCl4, what happens, that is this electrophilic addition we get, that is CH3 CH2 Cl, ethyl chloride will be formed, student. Then after that, now what to do, student? Ethyl chloride will be formed. This ethyl chloride react with same thing aqueous KOH, what happens, that is nucleophilic substitution reaction, we get, that is CH3 CH2 OH, ethyl alcohol will be formed, student. This is A compound, student. This is B compound, student. This conversion of from A to B, that is nucleophilic substitution reaction. Why? Because of the Cl minus is replaced by K plus plus and OH minus, the Cl minus replaced by OH, we get, that is ethyl alcohol will be formed, student. When ethyl alcohol again react with copper, student, copper at 300 degrees centigrade, student. What is the role of copper, student? This is also this copper at 300 degrees centigrade or PCC or PDC, these both reagents act as a dehydrogenating agent. That means oxidation reaction in this step is oxidation in this step is oxidation reaction, student. We get, that is CH3 CHO, aldehyde will be formed, student, that is aldehyde will be formed, that is C compound plus H2. What is the role of copper, student? This copper acts as a dehydrogenating agent and copper acts as an oxidizer. It can oxidize to primary alcohol. This primary alcohol's oxidation to give aldehyde, student. This is acetaldehyde will be formed, student. This acetaldehyde, student, this acetaldehyde again oxidation with KMnO4, student, KMnO4 or K2Cr2O7, we get, that is acid will be formed, that is CH3COH, CH3COH will be formed. This is a simple trick, student. When alcohols copper at 300 degrees centigrade to give aldehyde, then aldehyde again oxidation with KMnO4 or K2Cr2O7, we get, that is carboxylic acid will be formed, student. And direct step also involves, student. When ethyl alcohol, you remember, student, when ethyl alcohol directly conversion into acid, that is ethyl alcohol is converted into acid, that is in the presence of KMnO4 or K2Cr2O7, we get, that is CH3COOH. This is also possible, student. So conversion direct method, when ethyl alcohol oxidation by KMnO4 or K2Cr2O7, we get is acetic acid, or indirect method, when ethyl alcohol's oxidation by copper at 300 degrees centigrade to give aldehyde again oxidation by KMnO4 or K2Cr2O7, we get, that is acid will be formed. This is a simple trick, student. Conversion of from alkenes to acid, or one more conversion is there, student. When ethyl chloride, this ethyl chloride again react with potassium cyanide, KCN, potassium cyanide, what happens, that is K plus and Cl minus KCl is elimination, student. Here also nucleophilic substitution reaction, student. We get, that is CH3 CH2 Cn will be formed, that is propane nitrile will be formed, student. That is propane nitrile, that is CH3. Simply remember, student, K plus and Cl minus, we get KCl is elimination, remaining the Cn minus will attack this position. Here also same thing, student, nucleophilic substitution reaction is involved. In this step here, propane nitrile will be formed. This propane nitrile again react with hydrolysis, student. Hydrolysis, we get, that is cyanide on hydrolysis, we get, that is acid group, student. This cyano group is converted to acid group, student. That is simple trick, student. That is we get, that is product is CH3 CH2, same thing, student. From here to here same thing, does not change, CH3 CH2 as it is same. This carbon is converted into acid group. This you remember, student, cyanide, you remember, so this cyano group on hydrolysis, we get remaining part as usual same thing, CH2 same thing. This carbon is converted into COOH plus, and N is converted into NH3. This N is there, N is converted into NH3. This is the simple trick, student. So that is propanoic acid will be formed, this is acetic acid will be formed. Simple trick, student. This is the conversion of alkenes from acid from alkene. This is the simple trick, student. The CH3 in this step here also nucleophilic substitution reaction, student. The Cl minus is replaced by cyanide. We get that is propane nitrile will be formed. This propane nitrile on hydrolysis we get that is this cyano group is converted to acid and ammonia will be formed. You remember, student, CH2 CH3 CH2 will be same, CH3 CH2 will be same, but this C carbon is there. This carbon is converted to carboxylic acid group and nitrogen is converted to ammonia. This is the simple trick for conversion from alkene to acid, student. This is a simple trick, student. Please, thanks for watching, student. If you like my video, please like, share and comment, and thanks for watching, student. If you like my video, please click on like. Thank you.